Good afternoon, everybody, and welcome to this edition of TKI Offshore Energy Live. Will robots save us? Well, it's saving me at this moment because instead of learning the intro by heart, I have, thanks to AI, the luxury to read this intro text from the paper. And AI makes sure it still looks like I have my eyes on you. It's stunning, isn't it? But let's focus on the future of offshore energy. We are facing a large and growing shortage of offshore wind capacity to produce, install and maintain the offshore wind farms. And while there are now more than 600 turbines in the Dutch part of the North Sea, we need about 3 times as many by 2030 to reach the target of 21 gigawatts. Does the solution to the capacity shortage lie in robotics and autonomous solutions? Well, in this broadcast, we'll discuss the opportunities and pitfalls. All this on the 14th edition of TKI Offshore Energy Live. Let's start. And as always, as a viewer, you are welcome to ask your questions and remarks to our guests here via the chat or via the comments on the LinkedIn stream. So please do so. Bob, you will keep an eye on them.
Absolutely.
Yeah, good. Yeah. Let's start with our guest today. We are a guest in the Duurzaamheidsfabriek in Dordrecht. So Bram, let's start with you. You are the founder of TechBinder and you use technology to reduce dependence on people for various industries.
Exactly.
Perfect. In a moment, I will take a look at you in the surroundings we are here today. So I'm very excited about that. Welcome.
Thank you.
Then I move to Remco Streppel, responsible of offshore wind at Eneco.
Operations.
Operations, thank you for that. Welcome. And then at the other end of the table is Ties van Branisse, director of RoboHouse, a field lab at TU Delft where research is conducted into the interactions between humans and machines. We're very glad that you're here.
Thank you. Thank you for having me.
Yeah. And of course, on my left side, my trusted human intelligence, of course, in these broadcasts. I'm Bob Meijer, director of TKI Offshore Energy. Bob, first, briefly, a new name.
Yes, absolutely, Sophie. Thank you for the introduction. And we do have a new name, TKI Offshore Energy. Previously, we were called TKI Wind op Zee. That means offshore wind. But our scope has become much larger over the years. So we're also looking at, for example, offshore hydrogen production, all the offshore infrastructure in cables and pipelines and islands, but also new generation technologies like offshore solar. So we thought that offshore energy fitted better to our scope.
A better name for all the things you are doing. Yeah, very clear. So let's go on with the topic we're going to talk about today. Robotics and autonomous solution in offshore wind and their impact. Why this topic?
Yes, so we believe it's a very important topic for the longer-term developments and upscaling of offshore wind. And the reason is we are looking at an aging population on one hand, so there are less people to execute work, and an enormous upscaling of the amount of work. And that's a very bad combination. In our view, robotisation and autonomous solutions can provide a way out of this potential hurdle that we need to take. So we think it's a very important topic. It not only contributes to these potential shortages on the long term of labor, but it also supports, for example, better safety in working offshore. It can also reduce cost. So we really see it as a multi-edged sword.
Very good, very interesting also. Let's talk about it a little bit later. But before we get into it, let's take a look at the news that our guest noticed. Remco, can I start with you? What news did you see?
I think it's not one specific article, but in general, so there are general concerns about the amount of computing power and energy that the training of AI requires. And I think that's quite a concern. I even read that Microsoft is considering nuclear power plants for their data centers. So if you need a lot of robots and a lot of artificial brains, that also has a downside in terms of energy. So I think that's the other side of the coin.
we need to think about that also.
No, I think most people believe that the current models are brute force. And hopefully there will be enough scientific breakthroughs that models become more efficient, etc. But at the moment, they're extremely power hungry and need massive amounts of power, and that's a concern in my view.
And it will cost something too, on the other side.
Yeah, that power has to be generated, and it's not available for other things.
Okay, something to think about. Ties, what was your news?
Yeah, I wanted to draw a line between two different dashboards, and one of the dashboards is on the labor market, and the other is a news article from last week about 10,000 of healthcare employees that actually are striking, and it made a reference both to the car industry and the Actors Guild, which is also taking a strike. And the interesting one was, if you look at the labor market, you see there's a huge amount of tension in the labor markets, far more vacancies than people filling them. And on the other side, we have major strikes and also a concern for automation. That was actually mentioned in the article. And the interesting thing is that there's a discrepancy there. That automation taking over the jobs is still a major concern on the work floor, even though we're not able to fix the vacancies and the people that we have, that we require to run our economy and run our different sectors.
So is that education we need to think about, or?
I think it's a combination of education, but also involvement of the developments from the people on the work floor.
Yeah, in the process.
In the process of developing these prototypes. And the craftsmanship that people have on the work floor to make sure is that you highlight that when you develop a prototype or a new robotic application. And if you do that, then we're trying to do that in as many projects as we can. And then you see that the resistance between the employees and the robotic solution or the innovation manager, it fades away. Yeah. But that's a difficult, it's a discrepancy between innovation, high-tech solutions compared to the labor market, which you're currently seeing.
Interesting also. Thank you very much for that. Bram, what struck you in the news?
Yeah, well, maybe following up on the article that Ties mentioned is an article about the aging workforce. And we need to deal with a lot of experience and knowledge that will leave our employment. And the thing is, we see that coming for, let's say, 67 years, you might expect, but it's still it still strikes a lot of companies as a surprise, and that's an interesting thing, I think, to think about. And we need to start working on a different way of our knowledge management, because normally these persons that are going on pension leave take 30 to 40 years of experience with them in a specific site, on a specific plant, which is, I think, forgotten in this article, because yeah, we are losing a lot of people, but we are losing much more knowledge and skills as well.
It's not very positive news, I think. We have here a loss of knowledge. More
gives opportunities as well.
Yeah, opportunities as well. That's a good thing I like to hear. Bob, an item about AI caught your eye as well.
Yeah, absolutely. About AI, it was a paper published by Harvard Business School. And co-authors, and it is about, say, the productivity of office workers, you could say. And they've done some research with consultants using AI, and the results, I think, are really striking. So 12% more work done by people using AI, for example, ChatGPT. 25% higher quality, quicker work done, and 40% higher quality work. So that's really impressive numbers. People using AI as office support tools are better in their job, faster, and deliver a higher quality.
I'm glad we ended with your news. No, super. That's a good thing to hear. Thank you so much for that. As I mentioned before the news, we are at the Duurzaamheidsfabriek here. We have a lot of surroundings, beautiful surrounding here, and interesting surroundings. So Bram van der Boom, I didn't say your last name before. I invite you to walk with me and show me what it is you do here. So let's go. Yeah. Let's take a little hike here. And we're walking towards your digital demonstrator. Can you tell us, before we are there, what TechBinder does?
Yeah, so in basics, we improve the ways human and machine work together. And as stated on the table, there's a lot to gain if we start to use digital tools to support our daily work. The thing is that it is challenging to start a pilot, an effective pilot, in a normal organization that has its own rules, its own IT environment, etc. So what we've done here on the Excalibur flow loop in the Duurzaamheidsfabriek is created a digital playground for companies that like to do something with digital technology and like to experience it to improve the effect on their minimal valuable product in a pilot. And I can show you something.
Because this is the digital demonstrator.
Yeah.
You have it here.
Yeah, so you need to see this as one asset that is shouting signals and data and tries to talk to us. The only thing is we are not really listening. No.
Yeah.
And what we do is we translate what the system is saying towards instructions or information that can be used by a person in the field. So I can have a look inside of the cabinet, for instance, without opening it. But what I can do as well is start a procedure on how to connect that flow meter to a DCS system.
So if I have this, even I can do it.
You will be for sure capable of doing this. Yeah. Even though you've probably never heard of a DCS system.
No, I've never heard of it.
Yeah,
so,
no.
Yeah.
And what we say is, if the system tells the flow meter is not working, we can allow a person that's in the area to do this job. And that saves a lot of time traveling across the world. It saves a lot of time of our service engineers. And it empowers, like Bob said in his article, people to do things the first time right. And much faster as well, because all the information that they need is practically under their fingertips.
Right. What kind of companies are interested in this thing?
I would say practically everybody that's dependent on technology. So even the service engineer from the coffee machine could use this to help him to do a better and faster job. But we see the application being used in more critical environments, so factories, chemical factories, or areas that are difficult to reach. So in the maritime market or on chemical plants where you cannot simply walk in and do your thing.
Is it for every company?
Yeah, I would say yeah. If you have really small assets, it's always around the business case in the end. Yeah. So if you need to have if you have an asset that's capital intensive, yeah, the more capital intensive, the easier the business cases can be made.
And what do these companies gain in the end?
A lot. Higher uptime, because problems are solved much faster. Less training time, less dependency on specialists that they now need to keep in their teams, and much faster response towards any kinds of discrepancy in their operation.
Right. Thank you so much for your explanation, Bram. I will guide you back to your table.
Yeah.
But in the meantime, Bob, who is sitting over there, he will have some facts to kick off this minute, so to kick off the conversation. So, Bob, can you please start with that?
Thank you, Sophie and Bram, for this interesting presentation. And yes, we will dive into some facts and figures about the aging population, the demographics where we're looking at, which plays an important role, of course, in terms of labor market shortages that we may see. And in this graph, you see that we are comparing the Netherlands with Japan. And I think everybody is aware that in Japan, the aging population is that these problems are so big that they really have to find completely different solutions to also maintain productivity and maintain all societal services. Now, we're not in that same stage in the Netherlands or Northwestern Europe, but it's similar. So I think Japan is an interesting example of things that are ahead of us in that way. And if we go to the next slide, there you see the situation, and of course this is an illustration of the situation in Japan. And if you look at the demographics in the Netherlands in the year 2037, yeah, it's very clear. So that the peak is in the area of 67 years, or sorry, 76 years, and the demographic situation is like that. That we will need more and more people also in the younger age groups. Now, these are not there, and we will not solve that problem. So we have to find other solutions for this. And this is why we think this topic of robotisation and autonomous solutions is so important. So it is the demographics, combined with the enormous upscaling of offshore wind energy that poses these questions for us.
Super, Bob. Thank you very much for that. Bram, to start the conversation, what do you define under robotics and autonomous solution? What is your definition?
Yeah, it's good. So starting this conversation, we had a little discussion as well. So for me, a robot is not necessarily a physical thing. It can be a system that automates workforces, make decisions for you, takes data from system A to B. So it can be a digital thing as well. As long as it supports the workforce or does take over work that's normally done by a person. So that's for me the definition.
Okay, Ties, what's the definition that you use at RoboHouse?
What we often use in RoboHouse is the three terms sense, think, and act. So it senses the environment or the person that's connected to it. It thinks about how to respond to a certain situation using an AI model or embodied AI, and then it acts on the situation in the environment. And that can be either purely communication, so support or response or a signal, but it can also be a mechanical or physical action. That it takes for example, manipulating something, picking something up, or picking a tomato, in essence. And when you use that definition, there's a lot of tools in the offshore industry that we see as tools that already have a lot of components of robotics inside of them. Monopile gripper frames that position it vertically, specific cranes that have certain capabilities. And the more sensors we add to them, and the more we connect them to an AI model to think about decision making, then the more it becomes a robot, essentially. But we don't see them as robots.
Remco, when you hear these definitions, what do you think? What's your reaction on that?
Indeed, I also, in my view, it includes a hardware component to be able to sense and to manipulate in a physical world. And I think I tend to agree with this definition. It's not very. I think there is many. It's not a very clear definition as such, but I think most people sense that it's about something which is autonomous and able to find its way and do things that add value to our life, so to say. I think if you zoom out to the bigger picture, also what Bob mentioned about the aging workforce, I think we have a problem today, and I don't expect any miracles from robotics in the next 10, 20 years, to be honest. So I think if you see where we are currently and how big the problems are, I think we have to look much more at
it's not our miracle.
Looking at it's basically fighting the symptoms. We have to go back to the causes and basically look at low maintenance designs, smart solutions that basically eliminate work instead of robotize work.
So let's continue with that. Where in offshore wind are the highest needs for a solution of the shortage of people?
I think if I look at my day-to-day work, there's a shortage of technicians already, and we still want to install many new big wind farms, and I think that's a big challenge. And I just hired 4 technicians. They are coming from 4 different countries, even 2 outside the EU. So it shows how tight this labor market is. And I think we really have to be critical and we should go back to the drawing board to look at the design of turbines. And I think a nice example is, for example, bolt connections. You have thousands of bolt connections in a turbine. They all have to be checked and retorqued again. So that's a very labor-intensive, also a very annoying job. And I think there are smarter solutions. There's this nice Dutch startup, I think C1 Wedge Solutions. They've developed a solution that you can install and never have to check again. I think that's the type of solutions we need.
Yeah.
So we have to eliminate the work instead of trying to automate it. That's my personal view.
I think for new builds, that's a good thing, but probably you already have a lot of wind turbines out there with I don't know, what's the average lifespan of a windmill?
20 years, but we will try to operate them for 30 years, so to say. But I think still, if you look at the installed base, it's peanuts compared to our ambitions. So I think it's not sustainable to keep doing what we have done, because we don't have the labor for it. So we need to have better designs, which result in zero maintenance or low maintenance. And also in terms of production, I can imagine if you only produce 500 turbines of a specific model, that it's not sufficient to invest in a fully automated assembly line.
Yeah.
If you have bigger numbers, then you can invest in automated production. That saves also a lot of manpower in general. So I think all in all, we have to really be critical of how we do things today, because it's not sustainable if you want to scale up and want to accelerate the whole business.
We did a poll recently on LinkedIn and asked for, say, immediate application, so to say, of robotisation and autonomous solutions. And more than 40% said inspection work. Do you agree with that?
Absolutely. I think inspection work is also, where we already apply robotics. Because that's still the easy part.
Yeah.
But doing the repair, that's a much harder challenge.
Yeah. That was roughly 20%.
Yeah, so I think repairs, that's still very far away. But we use robots to do automated inspection of the blades. We use ROVs below the water, etc. So I think that's a good application, which is within our reach.
And censoring, I can imagine. There's a lot.
Censoring, of course.
Yeah.
But in the end, inspection is also, in terms of cost savings, that's only a small part of the overall expenditure. So the major expenses are within the repairs.
Yeah. So, Ties, at RoboHouse, you get a lot of questions to solve. I think the shortage of personnel. Can everything be automated? Well,
short answer is no. And the question that you always have is the expertise that a human being brings into a certain work process compared to the manual labor or the physical labor that's attached to that. And that's actually the boring, dull, the difficult work, and also sometimes dangerous work. I have an example from a different sector, which perhaps we can show. This is work been done together with KLM Engineering and Maintenance. These are titanium fan blades from wind turbines. And as you can see, this is manual labor. And these guys can sense and feel what they need to do in the fan blade to make them ready. So they are taken off the engine, they go through this process, and they can feel what kind of blending, what kind of repairs they need to do on the fan blade to make this work. Problem is, you can't do this for a very long time because your shoulders, your arms, your back, it's heavy labor. So what you see here is also several of my colleagues from the Delft University of Technology that are looking into this process and seeing what can we do in this process. Not necessarily to replace it, because there's so much skill involved in doing this. It's sometimes different machines that they have, I think, 15 or 16 different tools. And you see him here explaining they were really proud of what they did. So this is really awesome to be within this process as well. But to talk with them, what their expertise is, what their capabilities are within the process, and how technology can support that. And then you're looking not at as replacements for the people, but you're getting human-robot teams, more or less, which you're looking into that. So if we go to the next slide, so what you see here is we brought a robotic arm there. With the tool attached to it, and we let in a test setting, we let the people play with it, and we got a lot of feedback. It was the wrong tool, it was the wrong process, it was the wrong height, but hey, it can do this, it can do that, and they became involved into that process. We're currently working on the second prototype, also for an innovation fair, with a new tool attached to it, on the correct height, different programming. And then you get, hey, can we interact with these robots to do this together? The person does the quality work, he does the checking, he feels what needs to be done. But part of the load, for example, 50% of the vertical load is taken over by the robot. Or it can learn from the handling that the human being is doing, and it's able to do it 2 or 3 times after that. So that the physical labor, physical labor becomes less. And we try to do that in the projects that we run at RoboHouse to involve these employees and the expertise that they have. As you already mentioned, we're losing a lot of expertise, but not necessarily to replace that expertise, but to complement it, to take out the part that's not fun, not that doesn't give well-being in your work, compared to to leave that at the human being, to really check what the rest work is. When you implement a robot, to make that fun as well.
We also look at exoskeletons, for example.
It's in a different project. It's for the wires on the trains, above trains. So we're looking at exoskeletons, so taking off physical labor, but essentially an exoskeleton which response to the situation is getting very close to a robot as well.
I know, for example, I think it's BMW in Germany, they use exoskeletons for the aging population. So they have all the people working at the assembly line, and it enables them to work longer because the exoskeleton is basically taking the physical part of work.
And then the question is, what I think we always need to ask is, if you replace the work with a new technology or add a new technology, does that also improve the work quality? Because you can automate 50, 60, 80% of the job. But if it becomes so much less fun that you can't find the people doing it, so they'll go to the flitsbezorgers or other domains.
And maybe another question is well, my question is, what is in your experience when it comes to shifting labors? When work is taken over by robots, don't we just get a demand for different type of capabilities?
Yes, so you'll always need the different capabilities to maintain the robots, to be able to program them, to handle them. What you also see is that the people involved in the craft will also need to change their capabilities. So you really go to a craftsmanship 2.0, more or less. But you can really think about how that craftsmanship will look like. And that's in all sectors. It's from baggage handling to healthcare. The nurse now will not be the nurse in 10, 15 years. And I think that's the same for the offshore energy, the engineer as well. They'll have different skills. And if you take that into account when you design it, you can also design the right tools and technologies to actually support them.
But it impacts the process that we have in our organizations as well. And that's a difficult thing to change because we've done stuff for the last 100 years in a specific way. And now we have new tools, new ways of working. So we need to rethink the flow of information or the way that we've worked. And what we see is that can be a big challenge as well in existing companies.
But it requires also a lot of creativity to find these new solutions. And I think, of course, if you talk about, say my new colleague is a robot, you can visualize an android climbing up a turbine and doing things. But it's all embedded, as I hear from you and from you as well. And so the autonomous systems and the robotization is really deeper into the systems.
You can do more with less people, so that's a good thing, an answer to the aging workforce, inefficient. But on the other hand, the new guys and girls coming in are likely not to stay that long or less loyal to their employers as they used to be. So you will not see employment for 30 to 40 years. So the skills that a person builds up in a specific factory or in a specific area, you will not see that anymore. So we really need to rethink the way that we go with knowledge management, in a sense.
And there are pros and cons.
Exactly, always.
We hear sometimes a nice noise of this surroundings, which is great because people are working here. Very good. Bob, are there any questions in the chat?
So far not. I'm inviting everybody to come up with questions. And,
if you want.
Maybe it's all very clear. That's a possibility. And of course, we're also interested in say, feedback about these creative solutions. And so part of our innovation program is targeting these robotization and autonomous solutions. But the real solutions, well, they have to be invented, like, for example, you do.
And I think the good or the funny thing is that we discovered, at least in the period that we are doing this, is that it's not actually a technical question that we are solving. It's more a business question. So we have less people, less skills. Stuff needs to be safer, faster. And that we use technology for that. That's, I would say, a second thing. But approaching this from the technology side is not the right way because, the business case in the end is the important thing that makes this fly or not.
We identify it as a social technological problem. So it's the organization, you'll need to make sure that adapts to the new situation. The technology needs to adapt, but also the human being needs to adapt. So that triangle, we incorporate that in our research proposals.
But there needs to be an economic benefit.
Yes.
I think in the end. I think that's the challenge.
Gentlemen, thank you for this first part of the conversation because I want to shift our focus. There's someone waiting for us online, Jan-Willem Wagenaar of TNO. Welcome, Jan-Willem. He's Program Manager Wind Energy at Research Institute TNO. And TNO participates in a number of programs that work on robotics and autonomous solution in offshore wind. Jan-Willem, I think you can give us a view on what the future will bring us.
Well, That's a very challenging question. Anyhow, thank you very much for having me in this webinar. It's very interesting. I've been listening along, and you have some good discussions there. Thank you also for providing me an opportunity to glance through some innovations we are working on, and perhaps that is then a look through the future. And allow me to do that by addressing 3 questions. That's also how we have tackled our work so far. First question was, what technology, what robotic solutions do already exist, and how can we make best use of them? Second question is, what technology advancements need to be made in order to have these robotic solutions in the end implemented? And last but not least, what is the feasibility of such robotic solution? Had also been addressed in a table already a couple of minutes ago. So I'll start by addressing the first question: what is available and how can we make best use of it? When we make, let's say, an inventory, we came across robotic arms, we came across drones, we came across AR glasses, and say, okay, let's try and test this. And for that, we used the dummy nacelle of a Vestas V66 owned by Field Lab Severos. You can see the small picture in the middle where you can see that dummy nacelle, and just tested out these things, these robotic solutions, just to get a sense of feeling of what it means and understand practicalities. So, for instance, in the right top, you see a robotic arm simply pushing a button or opening a cabinet. Of course, these are simple tasks, and one may wonder, should a robotic arm do that? But it's just a demonstration of it. This is simply feasible. And then in the lower right, you see a drone in a cage flying around in a nacelle. And in the back, you see my colleague operating it. And this drone's inside the nacelle made inspections of the bolting. And was also mentioned before in the webinar. And what is the angle? Has the torque been, or the bolt been loosened? It also made inspections of temperature. Was there any heating or stuff like that? Simple tasks, just in order to demonstrate what is possible. And last but not least, on the left-hand side of this slide, you see my colleague wearing AR glasses. He is in direct connection with a colleague who is sitting outside the nacelle, and he is projecting information on his glasses. And you see his arm in thin air, so to say, basically interacting with his colleague who is outside the nacelle, addressing the topic of the expert being at a remote location. So if I then move on to the second question, what technology advancements need to be made? Basically, the position we take ourselves as TNO from wind perspective is to link inspection and maintenance tasks to robotic requirements. So what needs to be done, and how can this be taken up by robotic solutions? And then we look, for instance, at the payload of a drone, the sensoring in a drone or other robotic solutions. Look at the connectivity, look at navigation, all these kinds of, let's say, technical advancements. And allow me to address a few of them with some examples. So, for instance, if you look at payload and sensoring, we've been executing the AirTub project together with a large consortium, where AirTub stands for Automized Inspections and Repair of Turbine Blades. And this project is closed, and it was demonstrated that a drone could land a crawler on the blade. And basically, that is the picture on the right top. So a drone lands a crawler on the blade so that the crawler could do local inspections and perhaps also local repairs. In a follow-on project called AirTub Romy, where Romy stands for the residency of the drone, as the title suggests, we want to look at drones being resident at a wind turbine or wind farm, and also try to develop AirTub as a service so that service providers can take that up or operators themselves. And last but not least, we're engaged in this project called EBIS, Increased Blade Inspection Safety, which we execute together with SpectX. And SpectX is a company that uses X-ray detection. So in the picture on the right, you can see 2 drones. They carry this sensoring, and they make images of the interior of the blade. And furthermore, and that has also been addressed on the table, it's not about the censoring only, but also what you do with that information. So we like to use that information and use this censoring in a digital twin of a blade. And you can see that the picture on the bottom right there, where you feed a digital twin with the censoring in order to make estimates of, for instance, the remaining lifetime, how cracks will develop, stuff like that. And based upon that, make decisions on how repairs should be scheduled and when. But that was on the censoring and payload. If we move on a little bit, there's also advancements, technical advancements on connectivity and navigation. And if I start with the latter, our colleagues from Defense have executed the AURO project, which stands for Autonomous Underwater Remote Operation. And basically, that is all about navigation. If we want to have the robot to have autonomy, yeah, it needs to navigate itself. It needs to know where it is. For instance, if you have an inspection of a monopile and it sees something, yeah, is he on the same location? Is he seeing something he already saw before? Or is he at a different spot and is this a different crack or whatever? So navigation is very important and it requires technical advancement to do so. And an example is the connectivity. And so we've been talking about the censoring. We've been talking about how to use it. But of course, that information needs to be transferred from where it is measured, censored, to a location where it is being post-processed or where decisions are being taken upon. And this example, you see a drone making some pictures of some piece of blade material that doesn't matter too much, but it's flying in a hall where there's a whole 5G network. And on the picture right, you see a glimpse of a laptop. Basically, the person behind that laptop is physically about 100 kilometers apart from where the drone is operated. So it's really the expert at a distance, and it allows for a real-time interaction between the person who is looking at the images, making decisions, and the drone or the pilot who is operating it. And that allows for interaction. So it basically is a solution to the problem where drone makes images, for instance, what is happening now, flies back to the shore. Some people are analyzing it and say, shit, we missed something. We need to go back with the drone or something like that. So really, it's the interactivity that facilitates this connectivity. So that brings me to the last question. So there are technical advancements, but of course, the question is also what's the feasibility of such robotic solutions? And that has been addressed on the table as well. For instance, what are the economic or the finances? Does making use of robotics lower the costs? Is there a business case for it? Or is there any change in strategy, how you operate and maintain the wind farm? An aspect is safety. It's one of the arguments for having robotics offshore. It increases safety, but how then? Can we make that tangible? What is the most risky activity of offshore personnel, and how does making use of robotics lower that risk, and in what sense? Can we see less incidents? These kind of questions. The human capital has been addressed many times. Does it lower the amount of personnel? Well, what I understand from previous communications or conversations in the webinar and also from news items that apparently it increases also the quality. Well, that's a good selling point, I would say. And last but not least, also the carbon footprint. If you can avoid transferring with vessels, perhaps that also lowers emission. And that's also a good point for robotics. Basically, that we want to take up in two projects. One has started in the framework of GROW, called PRIMA, Pathways for Remote Inspection of Maintenance with USVs, unmanned service vessels. I really have to remember that because I have learned that in this field of robotics, there is an abundance of three-letter abbreviations. But anyhow, there we are going to address these aspects, and together with our colleagues from the Healthy Living Department in TNO, we also look at the social aspects. So how does an interaction between an engineer and a Google Glass or whatsoever, how does that change his or her behavior? How does he need to act differently, or how does he feel about it? So these kind of factors we also try to tackle in that project.
Willem, thank you. Thank you very much for this view. One question, what part in the process of the offshore wind will be the highest gain in the near future, do you think?
I think now it's on the inspection and the maintenance part. It's a lot of labor work, and I think there are robotic solutions who can take that up. Of course, that has been addressed on the table as well. You have to look at from a bigger picture, like are we doing things in the right way? But I think the low-hanging fruit is really on these specific tasks that can be robotized or automized.
Well, thank you so much for giving us this view. You will stay with us online. And before we are going to reflect on Jan Willem's presentation, I will ask you, the viewer, a question, because the question will be asked later at our guest as well. The question is, and please answer it via the chat if you like, what research question would you like to give Bob to work on as TKI Offshore Energy on the issue of robotics and autonomous solutions? That's my question for you. Please give that question in the chat so Bob can really work hard. I think.
I'm looking forward to it.
Remco, my question for you is: what is the most promising project in your opinion that Jan Willem just presented to us?
Now, I think you already mentioned it. I think inspection, I think, has the biggest potential on the short term. And I can really imagine that in the future we will have semi-autonomous aerial and underwater vehicles that maybe are resident in the wind farm. And that can save a lot of work and also creates a lot of extra opportunities. Because it all starts with knowing the status of your assets. And I think now you have to go there. And if you have like a resident vehicle that you can send for when you see something in your data, that would really help. Yeah. And I think that's within grasp. I think we see indeed more and more drones and underwater vehicles that can operate semi-autonomous. So
that needs our focus.
No, I think that's already what is happening, but I think that's something that is really has the biggest potential in the short term.
Thies, what are the most important stumbling blocks when companies wish to robotize?
I think that the technology part is one of the points. Well, we already mentioned it's not just a technical problem; it's also a social problem. The implementation and what we see is a lot of projects that technically are feasible and valid and very well developed, lack the implementation eventually. So I think that taking into account these different perspectives, economics was one thing mentioned, a response to AR, for example, what TNO mentioned. I think all these aspects, but also the psychology of the employee using it, the ethnography, the organizational change that you need to require. We see that it's important to take that into account from an early stage and not at the end where you have a technology and say throw it in the organization. So I think that's an important part to an important stumbling block that we see in projects that we've analyzed or looked at.
I would like to add one dimension. That's regulation. Because I think in general you see that it's not even allowed to have autonomous vehicles flying around or in the water. So I think in the legislation always lagging behind. And I think if we want to stimulate this development, we also have to make sure that the legal framework is enabling us. I think because I know, for example, I saw the Fugro example. I think they had quite a struggle to get even started with this pilot, to get permission even to use an uncrewed vessel. Because it was not possible according to legislation.
So legislation, what do you see as the biggest steps to be made when it comes to robotics in?
I think there needs to be space for pilots and research to maybe in a limited area, but to do experiments, to do trials. But because all the legislation is still aimed at manned airplanes and vessels with people on the bridge. And I think that's not catering the things we are discussing here.
That's a great suggestion, I think, to get also the legislators in some way involved in the research projects.
And then make the connection between a field lab environment where you can test and experiment. We saw the turbine nacelle, which was used for testing, but also make that connection to living lab environments where the operation is central, where you can actually start testing in a real life environment. Because there will always pop up things between a lab, a test lab, where you do a set of experiments to the real life situation, because there's always things that you don't expect. But if you can make that connection in advance and you make sure is that both sides are looking at the same problem, the flow becomes easier to bring it to market, bring it to the situation where you actually need it.
Yeah.
Bram, what do you think? You provide technology as a backup for humans, but should we blindly trust robots and autonomous solutions?
No. I think there's this example from the airspace, where they put some pilots in a simulator, and they let the plane crash without all the bells and whistles that would normally go off. So it's a highly automated environment, the plane, of course. And I believe that 30% of the pilots crashed in the end, or got in a dangerous situation. And we need to, so there's a flip side in this. If everything is automated and the system says no or yes, we are seriously in danger. So we need to have people that actually understand why an AI makes a specific decision or suggests something. But on the other hand, I think we need to see this as a normal navigation system in your car. Everybody uses it. Yeah, you trust, but you are not driving into the water. If it says turn right, you are the one that making the decision.
There is one advertisement that does.
Yeah, exactly. Well, that was the example. That I'm going to turn right here. Okay, and you are in the bushes. But so it is a play between some human intellect, I would say, as estimation of the situation. This can be a human that's sitting remotely, so it doesn't have to be a person on site. But as well, feeding the information or making content as easy to understand as possible for the person that needs to act and respond. And that's a nice area where we need to go for. So we can never go into a fully automated.
No. But on the other hand, if you see that the speed of developments of, for example, AI is spectacular over the last year or 6 months even.
And to add, when we used to have technology developments that develop technology on its own, so you would have AI, robotics, AR, VR, blockchain, data, it's IoT. But now it's something, they are designed to cooperate. And that means that you can connect functionality from AR to data with analytics, and you can do some ChatGPT stuff on top of it. And
talk to each other more.
That makes 1 and 1 3 or 4, and that's speeding up the development even more.
To connect to that, there is one of the main challenges is when you get into environments that change. So the automated car has been promised for 60, 70 years, and they still haven't fixed it. And even in LA, where it's now allowed, legislation, they do have collisions, accidents, and challenges.
There is no data from the future to learn these systems with.
So you need to. I think will be an interaction between human beings and the qualities that we perceive, also the things that we can do, especially in very large variances, so changes that we have that you need to handle, compared to the things that a robot can do well.
But I think it's a fact that the functionality that comes from technology is evolving way more rapidly than the rate of change that we as humans or systems, our companies can go up with. So. For management, it's very interesting to see, okay, what the gap between functionality available and the change of rate that we are capable of is growing rapidly. And for management, it's interesting to make the decision, what technology are we going to invest in? Because if you invest in the right technology, you will have a serious competitive advantage. If you invest in the wrong technology, in the wrong way, you will lose a lot of time and resources spending in a wrong direction. So and that gap is growing. So we need people with the flexibility, the creativity, but as well with the technology.
It's not also about natural selection, because I think the adoption rate for new technologies is increasing. And I think ChatGPT was the fast-growing app ever, because people saw the benefit. So I'm not so negative about. I think when technology is really having added value and people recognize it, I think people are more than willing to adopt it.
Yeah, but the way that we are working, so the processes that makes our business do what we need to do, changing those, the way that departments work together, information is shared.
Change is hard.
We do not like that. By default, we are not really liking change.
Remco, what is or should be, in your opinion, the main driver to apply robotics and autonomous solution in offshore renewables? That's the last question, I think. Because
I already mentioned. I think in it there must be an economic benefit.
Yeah,
I think
you told
most problems can be expressed in euros in the end. So if there's when there's really a step change feasible with robotics, I think it will be embraced. Yeah. I don't expect any resistance at all. If there's because the problems are big enough. So people are looking for solutions.
What's your take on this, Thies?
Yeah, I think that it's not purely an economic thing. That also work quality will play a role, and that's also what you see in people. The moment they have so much to choose in different sectors and different domains, is it the way you look at work? Is it the technology that you implement to make the work not just more efficient, but also a higher work quality? Will have a huge impact in whether you're not able to run your business. Or not.
Interesting that because we see lately that especially the young generation, they're not interested in working in shifts or working long hours. They really appreciate their social life.
Yes.
And that doesn't really match with offshore wind, where you want to use weather windows and want to work on every day, which has low waves. So I think there is indeed a tension between what we need and what people want, so to say.
Gentlemen, I think it's time to wrap up because the clock is ticking fast, and I think we can talk about this for hours still. Bob, you still wanted to say something, I think.
Yes, well, there's many things to say. Do you want to start a wrap-up?
First, let's ask, because I asked a viewer a question, and I would like to ask our guest that same question. So what kind of research or innovation questions would you like to hand to Bob on the matter of robotics and autonomous solutions in this offshore wind? Thies?
Yeah, for me, the combination between productivity on one side and work quality on the other, and looking at from all these different perspectives. So everything from organizational change, psychology, also the technical sides, of course, design. I think that will be an absolute requirement to make the right decisions on which technology to implement.
Thank you, Bob. Yeah, Bram?
Yeah, well, to add to that, so I think some research is done in other markets as well, but what are the minimal requirements for a company to have and for a pilot or a minimal valuable product to succeed? So are there stages in a project or what stakeholders to involve? And it's something that we are working on in this environment as well. But making the pilot succeed, a lot of the pilots, are not going into the right direction simply because the minimal requirements are not there yet. So what do we need as a company to be ready to adopt to these technologies, and what type of technologies would be feasible for our type of technology?
Interesting. Yeah.
Very interesting question. Bob was writing really fast, I think.
I see this assignments for our innovation program. So,
we're recording this, Bob, so we can give you a...
You have my number as well.
Remco, for you, the last...
Yeah, I won't. We should not start from scratch. I think the UK Offshore Wind Innovation Hub, I think they did a deep dive on robotics 2 years ago with a whole roadmap and everything. It's maybe good to revisit that from a TKI perspective and say, okay, what are the areas where we can contribute as a country and as an industry? Because I think this is a kind of a global challenge. This is not a local challenge.
Great suggestion.
Yeah, and if I may add, not only look at the wind industry, but go for food, for pharma, for chemical. There's a lot happening that can be applied directly into this market.
I like the work that's being done at TU Delft.
Yep, definitely.
Bob, I think there's a lot of work for you to do. Are you happy with the results of this edition?
I think so. Yeah, of course, if you look at the discussion around the table, first of all, we need it. So we will see this squeeze in terms of the labor force availability. We also see the demand, I think, for work-life balance is an important element. But there's also the other aspect, I think, the business case. It needs to tick, like you both suggested. So these are things, I think, that play an important role in future developments of, say, autonomous solutions and robotized solutions. I think it's also where Remco started with was avoid activities. It's also an important part of the puzzle, I think. So if you work from both ends, on one hand trying to avoid maintenance activities and inspection activities, and the other hand to improve productivity through robotized and autonomous solutions, yeah, then hopefully we will can counter this squeeze and make more benefits for the workforce in this way.
Fair. I'm closing because we're out of time, because we still can talk for hours, but I want to thank you, Bob. I think we will see each other on the 12th of December. What will the subject be then of the broadcast?
Yes, so the next theme will be offshore energy on demand. And then we're looking at to produce energy when it's required and not so much electricity when the wind blows. And so it's a systems integration challenge that we have there. And so offshore energy on demand. That's
a different issue.
That's the topic. Yeah.
Yes, looking forward to that one. Are any other events that we can look forward to?
Yes, well, I would say pencil in your schedule January 18th. Where we will have a meeting, I would say a matchmaking meeting, an information meeting about a coming subsidy, innovation subsidy call, the MOI, MOOI call that is opening again. There was one 2 years ago, very successful for offshore energy applications and developments. So we'll do this again. And on the 18th of January, there will be an event organized for this.
Okay, perfect. Gentlemen, thank you so much for this edition of TKI Offshore Energy Live. Thank you, Bob. Of course, thank you, Remco, Bram, and Ties. And thank you, the viewer, for watching. We'll hope to see you next time. For me, that will be on the 12th of December. Goodbye.